Suppose that S is a subset of 1, 2, 3, 25, such that the sum of any two not necessarily distinct elements of S is never element of S. What is the maximum number of elements S may contain? If K is the largest element in my set, let's write it down, largest, then I can pair up numbers from 1 through K minus 1 as 1 and K minus 1, 2 and K minus 2, 3 and K minus 3, and so on and so forth. Okay. And since K is in my group, I can choose at most one from each pair here. This should be fairly obvious because otherwise two elements add to a third in the group which violates the condition, right? So how many groups do I have here? It depends on the parity of K. If K is even, the last group has elements K over 2, K over 2, so it can be K over 2. If K is odd, the last group has elements K minus 1 over 2 and K plus 1 over 2, so it has K minus 1 over 2 elements at most. So all in all, here we can choose at most floor K over 2. This is indeed nothing but floor K over 2. And since we have one more element here, K, those two add to floor K over 2 plus 1 element at most. And since K is less or equal to than 25, this quantity is less or equal to than 25 over 2 floor plus 1, which is 13. So the number of elements that I can choose cannot exceed 13. All I need to do is to find an example that works for 13, and it's not really hard to see that numbers from 13 to 25 is a set which satisfies the conditions. So the answer is 13, B.